The role of a structural engineer, presented by Dr. S. Karthiyayani. Everyday life of a structural engineer. Structural engineer design and structural systems for buildings, bridges, dams, offshore platforms, etc. System means an assemblage of components with the specific objectives and goals and subject to certain constraints. Any constructed facility is a system. Structural system is one of its major subsystems. Components of the structural system have to meet design requirements of strength and stiffness while satisfying economy, buildability and durability criteria. Goals. Every system will have goals and specify what the system is to accomplish and how it will affect the environmental and other systems. They are made in statement of specific design objectives such as purpose, time limitation, cost limitation, environmental constraints. Construction standards, constraints. Restriction on the values of design variables that represent properties of the system which are under the control of the designer. For example, I-beam section of 200 mm depth may be desirable but not available. Standard. Value or range of values associated with each constraint. Codes and specifications. Structural engineering uses relevant codes and specifications in design of structures. A detailed set of rules and suggestions for design of a class of structures is called an engineering specifications. Codes are frequently formulated by the group of professionals with a view to their adoptions of their professions as a whole, revised at regular intervals. Design requirements. Principal design requirements of a structure is that it should be both buildable and fit for its purpose. Fitness for purpose, that is, its requirements of the constructed facility depends on the satisfaction of its structural and other requirements. Other design requirements include those of economy and harmony. Multidisciplinary project organization, that is, the owner representative as a project manager. Okay, it deals with some design professionals, that is engineer or architect. Lead design team leader. Team leader is nothing but structural engineer, electrical engineer, architect, or mechanical engineer, or civil engineer. Their supported disciplines are geotechnical engineering, surveying, space planning, urban planning, landscaping, and scheduling and estimating. Overall design process. First you have to identify the problem, that is definition of the problem, then consideration of alternative designs, primary designs, selection of site, modification, final design, final evaluation, documentation and executions. Structural design process, that is inventions or modification of structural system, preliminary analysis, proportioning members and joints, analysis, evaluation and final design. Design versus analysis, that is, in an analysis problem all the parameters are known, a unique solution can be arrived. For designer has to make several decisions, each of which could affect the final result. As a consequence, no unique solution can be offered. Design alternatives. Design for strength specifies that the design resistance of a structural component is greater than the required strength to transmit the load safely. Design for serviceability. In the serviceability design criteria for structures, the designer seeks to make the structure sufficiently stiff so that its deflection under the most adverse working load will not affect its serviceability. Factors considered in the design comparison. Materials to be used, arrangements and structural system and flooring system to be adapted, fabrication and type of jointing, method of erections of framework to be used, type of construction for floors, walls, cladding and finishes, installation of ventilating, heat plant, a lift, water supply, power, etc. Corrosion protection required, fire protection required, operating and maintenance cost. About steel. So structural configurations. Steel frame structures, that is braced frame, moment resisting frame, core and suspended floors, sawtooth roof, space frame roof, pylon, tapered portal, lattice girder. Introductions. Necessity for connections, limited length of members, rolling and transportation constraints, larger size of structures, importance of connections. Structure is only as strong as the weakest link. Connection failure is to be avoided before member failure. The full strength of member is to be utilized. Connection failure is usually not ductile. So some of the complicity of connections. These are the examples for complicity of connections. Reliability or safety of a design depends on variability of loads, variability of the member strength, variability of connection strength. Larger uncertainty of connection is due to complexity of connection geometry, highly indeterminate stress concentration, non-linearity due to slip and local yielding, geometric imperfection, residual stresses and strains. Complexity of geometry. See, this is a column and this is a bolt connections, this is a flange plate, this is a beam, this is a T-joint and this one is angle. So this is known as a bolted connection. For welded connections we will make it as bracket, okay, and stiffener. So geometric imperfection, bow in members are rolled, a lack of fit in black bolts in clearance holes, fabrication errors, members deflections, welding distortions, gaps and tolerance in fabrications and erections. Residual stresses and strains, differential cooling after hot rolling, gas cutting and welding, premature yielding under loading, lack of fit in bolted fabrications. Types of connections: welded connection, bolted connection and riveted connection. Welded connections, fillet welding and bed welding is there. For bolted connection, bearing type, friction type. Bearing type means carbon steel or high strength, or friction type means just highly yielded friction grips. Riveted connections, mild steel and high strength steel. Welded connections, so these are some examples for fillet welds and butt welds. Bolted connection, these are the bearing stress. These three are bearing stress, and this one is a clamping force, and this is frictional force. These both are frictional force. This is a contact pressures. So notice slip is slip in bearing type of connection. Slip we have to provide the slip. Friction type, no slip is observed in between the plates in HSFC connections. Merits and demerits. Welded connection, transfer of forces between elements more direct, requires little additional elements like gusset, shorter length of joints, no reduction in member strength due to bolt holes, etc. Rigid connection, easy to achieve, requires skilled manpower, requires special equipments, not easy to achieve at difficult locations, less ductile, prone to defects and fatigue cracks under cyclic loading. Bolted connections. Merits and demerits for bolted connections. Bearing type, easy to install even at difficult locations, economical, does not require highly skilled manpower, slip causes flexible joint size larger. For bolted connection, friction type, rigidity of connection, better fatigue performance, expensive due to material and installation labor, requires skilled manpower, requires better inspections. Semi-rigid. So, rigid of moment connections, types of connection, rigid, semi-rigid and rigid. Hinged joint. See, this is the rigid joint. Moment versus rotation means hinged joint, semi-rigid joint and rigid joint. Connection design philosophy. Connections are complex, the strength is variable, large numbers have to be designed, exact analysis, that is complex but possible. Accuracy depends on assumptions, not practically feasible. Practical, simplified methods are appropriate, should satisfy the equilibrium. Ductility requirements, that is static loading, fatigue strength requirements, that is cyclic loading. Transfer of member forces. So this is the connection and this is known as free body diagram. So this is the critical section for block shear. Force flow in a joint, high degree indeterminacy, local stress constructions, concentrations and yielding, effect of residual stress which is unknown, connection force flow analysis, making simplifying assumption, that is sharing of forces, satisfying equilibrium, ensuring adequacy of strength, ensuring adequacy of stiffness, ensuring adequacy of ductility. Cost of connections. Design cost consumes a major portion of efforts. Simplified design methods reduce the cost. Standardized design and details are desirable. Fabrications. Repetitive use of standard details. Good access, easy support, easy of joining at location. Mix of automatic and manual fabrications. Choice of connection methods. Other factors. Summary. So sound connection design requires understanding of their requirements, force flow, relative stiffness of elements and ductility of elements. Good design can considerably reduce the cost of steel structures. Thank you.